Hello, in this video we'll be taking a look at another application of derivatives in rates of change. It plays a very important role in finding the rates of change because the concepts behind derivatives, they change in a particular function, mostly the dependent variable with respect to an independent variable, is what we are going to be using here to evaluate the rates of change of various quantities. So let's take a look at some questions to explain this concept further. So the first question says that if the rate of change of the radius of a circle is 6 centimeters per second, find the rate of change of area of the circle when r is equal to 2 centimeter. So to obtain the solution for this, we've been told that the rate of change of the radius is 6 centimeters per second. And we also know that the area of a circle is equal to pi r squared. It means we can find the rate of change of area, that is dA dt. From knowledge of chain rule in calculus or in derivatives generally, we know that dA dt is equal to dA dr multiplied by dr dt. So we can get dA dr by finding the derivative of a with respect to r, and we have an idea of what dr dt is from the question. Therefore, we should do that. So we have dA dr is equal to 2 pi r, and the r dt is equal to 6 centimeters per second. It means the a dt now becomes 2 pi r into bracket 6, which is equal to 12 pi r. So when r is equal to 2 centimeters, the a dt will be equal to 12 pi multiplied by 2, which is equal to 24 pi centimeter squared per second. And this is going to give us the rate of change of area of the circle when r is equal to 2 centimeters. Let's take a look at another question. This question, we're told that the edge of a cube is increasing at a rate of 7 centimeters per second. We're required to find the rate of change of the area of the cube when x is equal to 6 centimeters. Let's take a look at this question. It's very easy, not something that should give any problems at all. If we know the rate at which the edge of a cube is increasing and we are required to find the area of the cube, what we just have to do is find the formula that is connecting the area, total area of the cube, to the length of its edge. So it means the area for a cube is equal to 6 multiplied by x squared. So dA dx is equal to 12x. And using the same idea as the previous question, we know that the A dt is equal to the A dx multiplied by the x dt. Therefore, the A dx, the A dt is equal to 12x multiplied by 7, and this is equal to 84x. So we now examine it when x is equal to 6 centimeters. Therefore, the A dt is equal to 84 multiplied by 6, and the A dt will be equal to 504 centimeters squared per second. The third question says that the total cost P of x in rupees associated with a product is given by P of x is equal to 0.4x squared plus 2x minus 10. Find the marginal cost if the number of units produced is 5. So before we solve this question, we first try to understand what marginal cost means. So marginal cost is the change in the total production cost that comes from making or producing one additional unit of the product. So any change that arises as a result of producing, or any change in the cost, the total production cost that arises as a result of producing an extra an extra unit or one more unit of the product is what we refer to as marginal cost. And mathematically, this is represented as, let's say, marginal cost is equal to delta C divided by delta Q. So delta C represents the change in cost and delta Q represents the change in quantity. So from this, it is evident that if the change in quantity is 1, then the marginal cost refers to the change in the cost that occurs due to that change in quantity. That's what the marginal cost is. So in this question, we know and calculus form, we can represent it as the C, the Q. In this case, our C is P and our Q is X. Therefore, the marginal cost will be equal to the P dx, and we have that P of X is equal to 0.4 x squared plus 2x minus 10. Therefore, the P dx is equal to 0.8x plus 2. Then we are told that if we should find the marginal cost when the production units or number of units is 5. So this becomes 0.8 multiplied by 5 plus 2, which is equal to 6 rupees. Therefore, the marginal cost is equal to 6 rupees. So take a look at one last question on rates of change. We've been told that the length of a rectangle is changing at a rate of 4 centimeters per second, and the area is also changing at a rate of 8 centimeters squared per second. So what will be the rate of change of width if the length is 4 centimeters and the width is 1 centimeter? So what we have been given is number one, the LDT as 4 centimeters per second. We've also been given the ADT as 8 centimeters squared per second, and we want to find the B, let's call it the W for width. The WDT is what we want to find. But we need to first establish that the area of a rectangle is the length multiplied by the breadth or the width. So A is equal to LW. So it's a function that depends on L and it also depends on W. So we can say that the A is equal to the A, the L, multiplied by the L, the T, plus the A, the W, multiplied by the W, the T, which is the A dt. Sorry. I use this because when we are taking the derivative of A with respect to L, we will consider W as a constant. It's called a partial derivative. And we're taking the derivative of A with respect to W, you keep L constant, and that's the partial derivative of A with respect to W. So the A dt is equal to the A dl in this case is W, the L dt, plus the A dw now is L, dw dt. So it's the W dt we are looking for. We know the L dt, we know L, we know W, and we know the A dt. So we can substitute that 8 is equal to 1 multiplied by 4 plus 4 dw dt. So it means 8 minus 4 is equal to 4 dw dt. Then 4 dw dt is equal to 4. That means the w dt is equal to 1 centimeters per second, and this is equal to the rate of change of width of the cube. With this, we've come to the end of this video on rates of change. I hope you guys enjoyed. See you in the next and final video of this playlist. and that's going to be on curve sketching.